All right. So I just wanted to watch a few seconds or minutes from a course about general relativity by Leonard Susskind, where he discusses the analogy of gravity as a fluid flow. Let's hear him.
Okay. So a point mass can be thought of as a concentrated divergence of the gravitational field right at the center. A point mass, a literal point mass, can be thought of as uh, a concentrated divergence of the gravitational field, concentrated in some very, very small little volume. Think of
Divergence just means a change of flow, a change in a vector field. So he's saying that, let's hear it again.
field, concentrated in some very, very small,
Again.
thought of the gravitational field right at the center. Point mass, a literal point mass.
Again.
And it falls off like 1 over r squared, exactly like the Newtonian field of a point mass. Okay. So a point mass can be thought of as a concentrated divergence of the gravitational field right at the center. A point mass, a literal point mass, can be thought of as a concentrated divergence of the gravitational field, concentrated in some very, very small little volume. Think of it, if you like, you can think of the gravitational field as the flow field or the velocity field of a fluid that's spreading out. Oh, incidentally, of course, I've got the sign wrong here. The real gravitational acceleration points inward, which is an indication that this divergence is negative. The divergence is more like a convergence, sucking fluid in. So the Newtonian gravitational field is isomorphic.
Right, so he's discussing here the Newtonian gravitational field, but general relativity in a primitive form, like for most, for our daily purposes, is Newtonian. And so if the Newtonian can be viewed as a fluid, then general relativity should also be the flow of a fluid.
Fluid in. So the Newtonian gravitational field is isomorphic, is mathematically equivalent or mathematically similar to a flow field, to a flow of water or whatever other fluid, where it's all
Flow of water.
equivalent or mathematically similar to a flow field, to a flow of water or whatever other fluid, where it's all being sucked out from a single point. And as you can see, the velocity field itself, or in this case, the field, the gravitational field, but the velocity field would go like 1 over r squared. That's
So the gravitational field is the velocity field. That's exactly how I derived it from first principles, basically. I mean, from the very thought experiment. Of course, in his mind, it's an analogy. I'm not saying that he agrees that actual space is flowing. I think he said it's not that space is flowing, it's just an analogy. But to me, that's impossible. You can't say that the moon is dragged into Earth by an analogy. That makes no sense. You have to say that the mechanism is the flow.
or in this case, the field, the gravitational field, but the velocity field would go like 1 over r squared. That's a useful analogy. That is not to say that space is a flow of anything.
It's a useful analogy. It's not to say that the space is a flow of anything. I don't know how you can say that. I mean, it's literally what you're saying. You're literally saying you have the flow of space. That's I don't know what else to say. It's the math. The math says it. Everything says it. I mean, this is so similar to every scientific revolution. Like every time some great physicist comes up with a formula, with equations, with a mathematical framework to explain some scientific phenomenon, and they say, yeah, it's just an analogy, it's just a mathematical tool, just a shortcut, it's just a trick, it's a mathematical trick to explain it's not real. And then the next revolutionary thinker comes and says, no, I'm going to actually take it seriously. I'm going to assume it's real. I know it contradicts intuition and so on, but I'm just going to assume it's real and continue from there. Like every revolution seems to have been just like that. Like we just take what what the ancient ones said, we just take it seriously. They proved it, every right. If the shoe fits, wear it. If you're assuming space is flowing, and that is that what the math says, then space is flowing, and deal with it. So space is a liquid. That's the assumption. So particles cannot move through this liquid. It's not really a liquid. It's particles cannot move through it, because if they could, there would be no speed limit. They could go at any speed. Particles don't seem to be able to move through this fluid. So, okay, let's continue. Even though he basically said everything I wanted him to say.
R squared. That's a useful analogy. That is not to say that space is a flow of anything. It's a mathematical analogy that's useful to understand the 1 over r squared force law, that it is mathematically similar to a field of velocity flow from a flow that's being generated right at the center at a point. Okay, that's a useful observation. But notice something else. Supposing now, instead of having the flow concentrated at the center.
Yeah, I think that's all I wanted to say. I mean, to me, it was obvious, but it's always nice. It's always nice to hear someone that I respect a lot, and he comes and says, This is so similar to every other historical scientific revolution. I mean, Planck, he invented H, and he said it's just stop. He said it's just a mathematical trick. It's just a mathematical tool. And then Einstein came and said, no, no, no. Like H mu is the energy of a photon or something like that. And De Broglie came and said, well, if you say a photon is both a wave and a particle, then then everything else. Why not everything else just as well? And let's predict that an electron is going to behave both as a particle and a wave. And that's the way I see it. I don't know if every scientific revolution went through such a step, but it happened again and again. I think there was a case where there was a negative sign. There was the square root. There was a negative solution, a positive solution. The negative is antimatter. I don't know if whoever was, I forgot his name. Like if you follow the math, and then they discovered antimatter because that's what the math says. You believe the math. You don't ignore it. You don't just ignore where the math leads you. In this case, it's not the math. In this case, it's the very thought experiment. If you actually listen to Newton, that he said, if you take him seriously, he said, gravity cannot be mediated over a vacuum. If you think it is, you're insane. That changed my mind quite a bit, I think. And then I heard different people talk about the ether that, it was never really rejected, But then I thought, the fabric of general relativity that Einstein kept referring to, or people keep referring to, this fabric that is bending and is curved. I don't know if it's curved and bending, but I had the impression it's something real there. And then you go through the thought experiment, especially with the elevator. If you're accelerating through the elevator, then you are moving through space. Then that means you have to assume that when you're on Earth, you are in the elevator, flying in space, flying in empty space through space. That means gravity must be showering space on right through us. That is what is demanded by Einstein's equivalence principle thought experiment. Anyway, I think that's enough. I'll stop here. It's just a little point. Okay, bye.